welcome back to the summer school on data privacy day 2. So we will continue uh, the session on intro to cryptography. So first, let me very quickly recollect what we did in the previous session. So first, we motivated the need for critical look at security through the IoT example, and then we also saw the role of crypto. We saw the applications of IoT, and then what some possible some security incidents, popular ones, and then we discussed our security for IoT cloud setting, and then what are the challenges, including what are the actors involved, right? And then we saw the role of cryptography, right? So basically, that's used to provide is a basic core of the TLS protocol, right? So that is used to provide authentication and confidentiality, right? And then we also saw that there's scope to use advanced crypto primitives to achieve privacy of the privacy for the data stored in the cloud, correct? Then we saw what is what is information security crypto, and then some historical use, core problems in crypto, and then briefly talked about this advanced applications, secure MPC, and then FHE, fully homomorphic encryption, and then we also discussed the need to implement these things securely, right? And then we saw the broad the overview of the information security, and then how it relates to other branches of study. So, and I'm sure you would have appreciated the intersection of law, the policies, and cryptography, right? Through Professor Sridhar's session yesterday, right? And then, okay, then we also look at other applications, important applications of crypto, and then what are the popular protocols used in these applications, right? HTTPS, Bitcoin, Zoom, and so on, right? And then, yeah, we suggested some references. We began with the study of symmetric key encryption. Then we defined what is an encryption scheme, asymmetric encryption scheme, and then we saw a very simple example of one-time pad. So where you just XOR the message with the key bit, the key string rather, right? And then you get back the message by XORing the ciphertext with the same key, right? So that's very simple. So the operation is XOR, but I mean, it need not be restricted to any. It's only the XOR, right? You can generalize it to any group. So your this operation, instead of XOR, it can be any group operation. For example, it can be modulo some number, say, right? May modulo any number n. So this can be easily generalized. And then we saw that, okay, we intuitively discussed that it's perfectly secure, meaning that you will not learn anything more information from the ciphertext than what you already knew about the underlying